going to talk about some math before you start doing your worksheet, okay? So remember, last week when we ended off, we were talking about the differences between factors and multiples, right? Because each number can be a factor, it can also be a multiple. I hope that you're thinking right now, oh, hey, I know what a factor and a multiple is, but just in case you forgot, we're going to go over it. Remember, a factor is any number that's being multiplied or it's also a number that can be used to find a product, right? This funny word, product. What does that mean again? The answer. A product is an answer. But it's an answer to what sort of question specifically? A multiplication problem. Good job. Okay, so a product is an answer to a multiplication problem. And factors are the numbers that are being multiplied, and it's also a number that can be used to find a specific product, right? Because not all products have the same factors, right? And remember that multiples are any number, are numbers that can be found by repeating a number. So basically, it's repeated what? Addition. I hope somebody said that. Right? So you have factors, and then you have multiples, right? And we remember that a multiple is basically a answer. An answer that you got from your factors can also be considered a multiple. Right. Now we're going to go back and review how to find the factors for a specific number, right? So if I wanted to look at the number, let's just use 20, right? I'm looking at the number 20, and we talked about two ways that we can find factors, right? We talked about how we could use rainbows, and we talked about how we could use tables. And I told you that you can use whichever one of those makes more sense to you. If you like the rainbows better, use the rainbows. If you like the tables better, use the tables, right? So remember, when we're finding factors, we can always start with what number? I hope you said number 1. So we're going to write it down. Number 1, and when I arch my rainbow across, what goes on the other side? 1 times 20. Good. I hope somebody said that. So after 1, then we try the number 2. So we need to figure out if we can fit 2 into 20. So remember, if we're thinking about our divisibility rules, right, we know that if a number ends in 0, 2, 4, 6, or 8, that number can be divided by 2, right? So 20 ends with a 0, so that means that we can divide 20 into 2. Some of you are already thinking, oh, Miss Burkhardt, this is so easy. If I take 20 and divide it by 2, what times 2 is going to equal 20? 10. It's 10. Great job. So I would put my 2, I would pull it across, and I would put 10. So now I've done 1, and now I've done 2, and so now I need to look at 3. Right. So if I have, so the question is, can I divide 20 into equal groups of 3? So let's try it out. I've got my 3 groups, 1, 2, 3, and I can start by 5s, right? So I can do 5, 10, 15. I can't do it by 5s again because then I'd automatically have 20. So I have to stop there. So I have 5, 10, 15, 16, 17, 18, 19, 20. So these two groups have 7 and this group has 6. So can I divide 20 into 3 evenly? Nope, sure can't. So we got to erase that one. That one doesn't work. So 3 didn't work, so next up on the list is 4. So once again, I'll draw out my 4. Some of you may already know the math facts of this, and that's great. If you do, fantastic. So I've got my 4 equal groups. I'm trying to figure out if I can get 20 in there. So let's maybe try starting out with 5. So 5, 10, 15, 20. There's 5 in each group. So can I put 20 into 4 equal groups? Yes, I can. Right? Because I have 4 equal groups of 5. So on my rainbow, I'll put a 4, pull it across, and put a 5. So now if you notice back on our rainbow, we went from 4 and our next one's 5. So now we can stop because we already know that if I went to 5, it would then be 5 times 4. And then I would just keep going and going and going until I got all the way to 20. And we've already got all those. So we can stop. So we have all of these as our factors. 1, 2, 4, 5, 10, and 20 are all the factors of 20. Right? And it would look the same on the table, except for instead of using a rainbow, it would look like a table. So I have my table, I have 20 on top, and now I'd start with 1, and beside it, I could write 20. We've already done the work, so we'll just fill it in from there. So I would have 2, and then I could just write 10. And I would have 4, and then I could just write 5. And so once again, I already know that I'm done with this. But the next part is to remember that you need to be able to write equations that match with it. So if I'm looking at the rainbow, I know that I can go 1 times 20 or 20 times 1, right? So I can do 1 times 20 or I can do 20 times 1. And then I would move on to the next one. So I could do 2 times 10 or 10 times 2. Then I would move on again. 4 times 5 or 5 times 4. So these are all the possible equations. 1, 2, 4, 5, 10, 20 are your factors of 20. 20 is a multiple of 2. 20 is a multiple of 5. Because I can use 5, I can use repeated addition, and I can get to 20 from that. So, factor rainbows, factor tables. So now, quick question for you. The number 20, is it a prime number or a composite number? I'm going to give you 5 seconds to think about the difference between prime and composite. And the answer is composite. Why is it a composite number? Because I can get to the number 20 in 1, 2, 3 different ways, right? And remember, a prime number can only be found by multiplying it by itself. And 1. So I could use 1 times 20, but that's not the only way that I can find 20. I can also use 2 times 10 and 4 times 5. So that makes it composite because it's not like 1 times 20 is my only option, right? So this is a review of factors versus multiples, and you're about to get a worksheet from Mr. Garrett that has factors and it might have a few multiples on there. All right, there's 2 more things that you need to know before you get started on the worksheet that Mr. Garrett's about to give you. So the first one is something called the greatest common factor. All right, the greatest common factor. So what that's asking you for, it's going to give you two different numbers, and in those numbers, you're going to have to figure out the factors for those, right? We already did the work for 20 just a little bit ago, so I just went ahead and wrote it. 1, 2, 4, 5, 10, and 20, right? And the factors are listed down here. So if I wanted to do the same thing for 30, 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. All right? Those are my factors for 30. 1, 2, 3, 5, 6, 10, 15, and 30. So what this is asking you for is which factor out of these factors for 20 and these factors for 30, what is the biggest one that they both have that matches? Which one do they have in common, and which one's the biggest out of the ones that they have in common, right? So there's 30 is the biggest number here, but there's not a 30 on this side, so that one doesn't work. So there's a 15 over here, but there's not a 15 on this side, so that one doesn't work. So there's a 10 over here, and there is a 10 on this side. And the only number that's bigger than 10 on this side is 20, so the greatest common factor in this situation would be 10. Okay? The other one is the least common multiple. In this situation, you are finding the multiples or using repeated addition in order to find multiples. They'll give you two different numbers once again, right? So in this situation, we have 3 and we have 7. So if I'm going to make the multiples out of this, I'm always going to start with 0 because 0 is a multiple, all right? Because when we start counting, it's like 0, 3, 6, so on and so forth. So if I'm doing 3, we'll just do the first 5 of each and see where we get to. So if I'm doing 3, I have 0, 3, and then I have 6, and then I have 9, and then I have 12, right? So these are our first 5 here. 0, 3, 6, 9, 12. So now we're going to start with 7. We'll do the first 5 with 7, right? So we have 0 at the beginning, and then we'll have 7, and then it's what? 14, and then it's what? 21, and then 28. So now what we're going to do is we're going to check and see if any of our numbers match up. Okay? Don't count 0 because all of them have zeros. Alright? So we're not looking at the 0. So if they both have zeros, so we're looking for the least common multiple. So the smallest number that if you're using the multiples, the smallest number that they would have in common. So right now we have 0, 3, 6, 9, 12. 0, 7, 14, 21, 18. Any of those numbers match? No, they don't match. So let's keep going. So let's go back to 3. We have 3, 6, 9, 12, and then there will be what? 15, and then 18, and then 21. Huh. What do you notice about that? 21, 21. Those are the same numbers. So the least common multiple is 21. Because 21 is a multiple of 3, 21 is a multiple of 7, and it's the first one that they have in common. It's the smallest number that those two numbers, the smallest multiple that those two numbers have in common. Alright? I know that I'm not there to help you with this, so you can just keep this up on your screen and rewatch the video if you need to while you're doing the worksheet. But if you get way too confused on it, don't worry about it. I will help you when I get back, okay? So just do the best you can on the worksheet, and if you get super confused, don't panic. I will help you when I get back on Wednesday, all right? So get the worksheet from Mr. Garrett, get to work, all right? Try your hardest, but don't forget, all right? Okay.